Now to the next technology showcase, Enlight software session. Integrated data center management, energy savings, reduce costs, and improve resiliency through integration. Data centers have never been more vital or central to business operations. We know it. Yet they need to be ever more efficient, resilient, and flexible. This session is really going to be looking at integrated data center management, an approach to achieve these objectives by integrating the numerous layers within the data center, from critical infrastructure and the building itself, with IT and workloads. Specific, high-value use cases will be detailed, and foundational approaches such as cooling chain will be introduced. And of course, our presenter today is Enzo Greco. He's the Chief Strategy Officer for Enlight Software, someone we've known an incredibly long time. And Enzo's responsibility over at Enlight is their strategy and direction based on market trends and dynamics, partnerships, and of course, all the adjacent markets. Now, don't forget, please take a look at all the information that's available, and for more information on Enzo himself, take a look at his bio on the left. So, I'll be back as we get to your questions, but right now, over to you, Enzo.
Stephen, thank you so much for that introduction, and my thanks to everyone in the audience participating in this webinar. And what a great and interesting topic we have. I think all of us in the data center market are aware of how we have all of these different systems in the data center that aren't quite integrated, everything from the building to workloads and everything in between. They've all traditionally been fiercely independent, and with all of the demands on data centers, they need to be integrated. And in this session, I'm delighted to present an area that we've been spearheading called Integrated Data Center Management. So data centers are fascinating. I think many people have never seen one. Many people don't appreciate that they exist. But every time we open Office 365, every time we use an ATM, somewhere in the background there's a data center that is serving us. And data centers, as we've seen in the last year, have never been more vital. They've never been more important to business, but they are coming under ever greater scrutiny for efficiency, for availability, for flexibility, because there's so many options in where we can run workloads. And the best way of achieving these different imperatives is by tightly integrating all the different pieces in the data center, from the building itself to critical infrastructure to IT and workloads. And this is the area of integrated data center management. So as we just mentioned on the prior slide, when you are able to integrate all the different systems within the data center in new ways, unique ways, you get several significant benefits that we'll emphasize throughout this presentation. You get everything from energy savings, reduced cost, higher resiliency, higher availability, higher flexibility. And integrated data center management is exactly the state of the art. It integrates all of the different systems. It provides a level of insight, a level of control that we need in today's computing environment. And in fact, I welcome you to look at the following very short video to have a better understanding of integrated data center management before we review it in more detail.
IDCM, or Integrated Data Center Infrastructure Management, is about integrating building management and automation systems with data center infrastructure management systems. The objective is to jointly manage the critical infrastructure that data center resources continually rely on to run and optimize the application workloads running in them. IDCM is a valuable tool for managers of critical facilities and data center operations, providing controls for improved capacity management of power, cooling, and space, reduced energy utilization, and in turn lower operating costs, and ultimately the improved uptime of individual workloads. Key indicators identifying the need for IDCM include the lack of visibility and management across the hybrid computing fabric, a lack of end-to-end power, cooling, and space capacity management, no integration between building and IT infrastructure teams and systems, or end-to-end automation of workflows, resulting in unexpected customer disruptions during planned maintenance activities, as well as the ability to optimally scale the critical infrastructure to meet IT needs and customer critical workloads. Some IDCM use cases include asset management across the entire hybrid cloud infrastructure, mapping power and cooling to local events and workloads, initiating automated workflows to address alarms and anomalies in the infrastructure triggered by power, cooling, and security anomalies, and with machine learning, the analysis of multivariate telemetry, including end-to-end energy prediction and optimization. For more information on how your organization can achieve better capacity management, increase the efficiency of existing resources, and perform more streamlined workflows and operations across all of the IT stack with IDCM, visit nlight.com and ask for a demo today.
At their base level, data centers are buildings, but they are different than any other kind of building in how the building and the critical infrastructure itself is modified, should change by what's running inside of it. Depending on the workloads we're running, we probably want to run our chillers different. Depending on the security of the applications, maybe we want to reconfigure the physical, the perimeter security. That's what we should do. That's what we want to do. But rarely do we do that. So integrated data center management is exactly that approach to integrate all of these different systems, again, from the building to the workloads, so that everything is integrated, everything is optimized. And to achieve this, you need a couple of major components. One of the biggest is you need a building automation system or a building management system. And we've partnered with Automated Logic, which is one of the largest providers of BAS systems to data centers. And we, nLight, we provide that knowledge of the data center itself, of IT, of racks, of workloads, of power chains, and as we'll see in a minute, of cooling chains. The approach we took in defining and building integrated data center management was to focus on use cases rather than taking an approach of building it and they will come. In the market that we are all in, we know that it's so much focused in terms of the functionality that's needed, the return that's required. So we focused on a couple of key areas. Better capacity management, and when you have better capacity management, you're able to manage your assets better. You're able to have much better visibility into your power, your cooling, in how they affect downstream assets. So better capacity management by integrating the building with the workloads. Reduce costs and energy utilization. Why do we run our chiller systems on a Sunday morning the same way as we do on a Tuesday morning? Very different workloads. If the building had insight into the workloads, we're able to tailor that critical infrastructure. We're able to tailor the set points and all the other factors that we have control over to much better match the demand with what the building itself needs to provide. And finally, improved uptime. If we have concepts of different power chains have different risks, different data centers may have different risks in terms of security, stability, power availability, and so forth. So we're able to improve uptime. And so overall, integrated data center management delivers via use cases these major areas of benefit: better capacity management, reduced costs, and improved uptime. I want to take a minute and give an example of some of the very valuable and unique functionality we've built into integrated data center management. So I'm sure we're all familiar with the power chain and the value and the utility that a power chain provides. But in a data center, what we've introduced is the concept of a cooling chain. Same concept as a power chain, but with very flexible endpoints in defining my cooling system. So whether it's starting at a chiller or at an air handler, I can define what are the assets that are associated with a particular cooling chain. And this is really important because as important as a power chain is, typically our cooling systems go under ever greater maintenance. Since they're mechanical, they tend to have more failures. We tend to have both scheduled and unscheduled events on cooling chains. So one of the things that we've defined in integrated data center management, and here's where the partnership with automated logic really comes into play, is by defining this cooling chain, we can now determine if a given chiller fails, what are the downstream assets that are affected, whether it's a rack, whether it's a server, whether it's the user that is associated with those racks and workloads. So by introducing this cooling chain, this is really fundamental to many of the other benefits in integrated data center management. So even though we've only had the luxury of scratching the surface of integrated data center management, I think we can start to see some of the benefits. And I just want to highlight a few here. And we have touched on these throughout, but I just wanted to summarize them in one place. One of the biggest, and especially in this era of sustainability and the focus on efficiency, is by integrating all of those systems, we get increased efficiency. Our chillers are matched to workloads. As simple as that concept sounds, that's what we get through integrated data center management. I think for many of us, that is a very large goal. We get much better effectiveness from our processes, from our workloads, from our staff, because now they are able to understand what are the downstream effects. If I make a change, what is the actual impact? I get reduced risk of outages because now again I have much better visibility into all of the connected systems. I know if a change is made, what is the potential impact of that? And I'm able to have workflows that span the entire environment from, again, the building up to workloads. And that goes into improved resiliency and efficiency. And this is a concept, the last bullet, is in the market there's this concept of a digital twin. And that's exactly what we are emphasizing here. And a digital twin is simply simulating, mimicking your physical environment in a virtual way so that you can make changes, you can do what-if environments. And what we have done in integrated data center management is extend the digital twin to the concept of incorporating all of the different systems in a data center. Again, from the physical to IT to virtual. So even though in this presentation we only had the ability to summarize some of the high points of integrated data center management, we have prepared a wealth of resources, from white papers to presentations to webinars. There's a great IDCM for Dummies book, and I welcome you, I urge you to download these resources. Send me a note. I certainly enjoy speaking on the topic, but I also enjoy learning from the audience, learning from people that I work with in this area. So there's a wealth of resources already available. You please feel free to contact myself, Enlight, Automated Logic, if you have questions on BMS. And again, I thank you very much for your time and attention on this call. And Stephen, I'll send it back to you. Thank you.
Enzo, a lot of folks in the community are asking the same question. It has to do with the data center fleet. And that is, how does IDCM work in an edge deployment? Enzo, a lot of folks need to know. Help us here.
So let me think this through. One of the biggest issues in edge, of course, is autonomous management, because almost by definition, they're remote. We don't have the luxury of walking the halls. So what we really need to have is autonomous, intelligent management that integrates, even more so than in an enterprise data center almost. You need to have systems that understand when I get a critical facility failure, how does that affect my workloads, and vice versa. If I have an application failure, is there something that the critical facility should do? So I think in an edge environment, integrated data center management is equally important, and in fact even more so, because we don't have the luxury of having human intervention. So all the different systems need to be integrated even that much more so.
You've spoken about the systems, which is perfect for the next question from the industry, and that is, what key indicators would drive IDCM?
I can speak from firsthand experience where I've seen customers focus on this area. One of the most important is capacity alignment. Do you have enough critical infrastructure capacity, or do you have too much? Do you have, so certainly capacity alignment, both on the critical infrastructure and how it aligns with IT is probably one of the most important indicators. Another one is newer metrics. Once we're able to integrate these systems together, we get new metrics like what's the cost per workload? What's the risk per workload? Because not all data centers are built the same. Within a data center, not all racks and rows are the same. So can we assign a cost and a risk per workload? And then I think the last one is how effectively are we managing scheduled and unscheduled downtime? And again, as we said before, thermal systems, just by their nature, tend to have the largest events that affect them. How well are we able to schedule them? When we take a chiller for maintenance, for example, are we able to manage the workloads and the customers that are associated with it? So from firsthand, I would say those are three of the biggest indicators.
Getting to know those indicators is key, and thank you for that. That's really great insight. Next major question coming up from quite a few folks is around multiple data centers. People are managing multiple data centers with multiple building automation systems, with multiple platforms. Does IDCM function in a multi-BAS environment? Is it possible?
It is, and in fact, it's a lot more common than it should be. This is a truly fragmented market, I think, as we can all acknowledge. There are many different kinds of data centers, and within each data center, there tend to be many different providers of equipment and critical infrastructure, and that includes BMSs. One of the biggest requirements from customers, even from single customers that have many data centers, is each one of their data centers is a bit different, with different systems, different procedures, different BMSs. So one of the specific areas that we built into IDCM is the way to work with multiple data centers first. So you have to have the ability to aggregate across data centers. But also you have to be able to virtualize the BMSs within different data centers, assuming that you have multiple BMSs. So the short answer to your question is yes, we're able to aggregate multiple data centers, and we're able to virtualize multiple BMSs to provide a single consistent view across the computing fleet, as you said at the beginning.
Enzo, thank you, but I've got to apologize right now. We've just run out of time, and I know that there's quite a few folks that want to reach out to you and everyone else at Nlyte. So to you and to your entire team, thank you for all you do.
Stephen, I really appreciate you sponsoring this. My thanks to DCD for the opportunity, and my thanks to everybody in the audience for the time and the intention that they spent.